one of the consequences of the hype and the exaggeration that sometimes attends big data, I think, is that the labels and the definitions that we use to describe the field get overloaded very quickly. And I think that one of the labels that we risk overloading to the point of complete abstraction at the moment is this idea, this concept of a data lake. There's a lot of discussion in the industry at the moment about data lakes. And to read some of that commentary, you could almost believe that the data lake is the prototypical use of the Hadoop technology stack. But actual referenceable data lake implementations are much, much smaller in number than Hadoop deployments. And there's a real shortage, I think, of documented best practice that can actually tell you how to go about building a data lake. If you search for data lake, for example, on amazon.co.uk, the top hit is this academic textbook on tracking environmental change by looking at lake sediment data, which might not be exactly what you had in mind. So if the data lake is more architectural concept than physical reality in most of our organizations, at least today, I think now is a really interesting time to ask ourselves, what is a data lake anyway? What would we like it to be? And what do we want it not to be? I think if you cut through the hype, most of the commentary about the data lake is about three big ideas. Big idea number one is that we're going to store all the data in a centralized Hadoop-based repository. We have to think a little bit about what all the data actually means, but that's a subject for another time, another day. Big idea number two is that we're going to capture and store in this repository raw, unmodeled data and apply lake binding techniques to interpret that data, potentially multiple different schemas so that we can have multiple different interpretations of the same data sets. And big idea number three is that by doing these things, we're going to remove barriers to data accessibility and data integration. Now, that's a lofty and a worthwhile ambition, but at this point in the discussion, some of you could be forgiven for a certain sense of déjà vu, because I think improving data accessibility and integration is what many of us have been building data warehouses for. So I think the first question we have to ask ourselves is, are we actually building a new construct here? Is the data lake a new architectural construct, or are we just replatforming existing analytic solutions? And if we're just replatforming existing analytic solutions, what are the consequences for replatforming those solutions on the current Hadoop technology stack? I see a lot of companies building analytic solutions on Hadoop that look a little bit like this. Simple, single subject area, dimensional models with all of the dimensions pre-joined to a fact table in an ETL process at load time. Now, there is a place in most of our organizations for application-specific data stores. But I think we have to be honest with ourselves. Solutions that look like this aren't about breaking down barriers and organizational silos. In fact, they actually probably represent the next generation of information silos in very many of our organizations. And if this is the future of enterprise analytics, then to some of us that lived through the 90s, it looks a lot like the past. It looks a lot like the Inman versus Kimball debates of the late 90s. And those of us that lived through those debates know actually that the answer that most of the industry came to was that it wasn't Inman or Kimball, it was Inman and Kimball. So I think we can do better than this, and I think that we should be very much more ambitious for the technology that Doug Cutting and all have given us as well. I think if you take the merits of the different technologies off the table for a minute, what a lot of us are thinking is this. You know, the difficult and the time-consuming part of a traditional business intelligence and analytics project is the upfront data modeling and the data integration processing. Maybe we just shouldn't bother with them anymore. You know, traditional approaches to data integration involve a lot of difficult and unglamorous work. To understand and model data, we have to do that work up front. And critically, because we have to do that work up front, we have to do that work very early in the process and often before we have a clear understanding either of requirements or of the value of the new analytics. And that makes the idea of a frictionless data acquisition process, data lake big idea number two, very, very appealing indeed. But I think we also have to recognize that in information management, there are no free lunches. Information management is fundamentally about engineering, and in engineering, there are no free lunches. There are just different trade-offs, just different compromises. So-called schemaless data management is a brilliant technique for capturing and managing data whose structure changes continuously. Those of you in this room who are capturing raw device log data probably aren't modeling that data, or at least all of that data relationally. Because if you do, then you're at risk of having to change the target data model and the associated ETL processes every time you download and distribute new firmware to those devices that change the data those devices can capture about themselves and about their environment. And that's a very time-consuming, very difficult, very inflexible process to go through. But of course, the flip side of flexibility is, well, flexibility. When we give users and application developers multiple ways of interpreting the data, we also give them multiple ways of interpreting the data incorrectly and making bad decisions rather than good decisions. And it's very, very much harder to assure data quality without a predefined schema. And a well-designed and well-implemented schema-on-load implementation gives us opportunities to optimize access paths so that we can help more users make more use of more valuable data. I think put very simply, it's not that schema-on-load is bad and schema-on-read is good. It's that both of those different techniques have more or less value for particular analytic data sets and for particular analytic use cases. I think it's very, very clear now that pretty much, or it's pretty significant, that pretty much the whole industry has now coalesced around this idea of a distributed big data architecture. I think it's very clear that there is no single silver bullet information management strategy, still less a single silver bullet information management technology that addresses the entire spectrum of big data requirements. We're all coalescing around this idea of a distributed big data architecture, even if we can't all agree yet what we should call it. Some of us call it a logical data warehouse. Some of us call it an enterprise data hub. Some of us call it a unified data architecture. For me, at least, those are all synonyms for the same thing. And the important idea is that there will be multiple platforms, so that integration of those multiple platforms becomes a critical consideration for all of us. So now I think we know what we want the data lake not to be. We don't want the data lake to be a retread of the departmental data marts that many of us have spent the last decade consolidating into an integrated data warehouse. And now I think also we have a much clearer idea of what we do want the data lake to be. A centralized repository of unmodeled data, particularly complex multi-structured data, so that we can capture that data and apply efficient computation of the kind of things that traditional relational database management systems find it difficult to do. So enterprise search that works, natural language processing and text analytics so that we can understand not just what customers have done, but what they're saying and thinking. Graph analytics so that we can understand who they're sharing those insights with and who's who in the social graph. And machine learning at Internet of Scale things. And we want to do all of that cost effectively and at scale. And we want to do that in an agile manner so that we can build a haystack to go and look for needles in. Now that is new for most of us and potentially very, very valuable. Now why do I say potentially very, very valuable? Well, I get very, very nervous at this point in the discussion when a lot of the analysts and commentators start talking about governance and metadata management in the data lake. And some commentators seem to apply that we don't need any governance or any metadata management in the data lake, that we should delegate all responsibility for understanding the data to end users, to application designers and developers. And the justification goes something like this. Well, this is just an exploration and discovery capability. This is just about research. Therefore, those things are superfluous. Therefore, those things are unnecessary. I have to tell you, I profoundly disagree. I was briefly a research scientist, not a terribly good research scientist. But the one thing I did learn is that the basis of all experimental science, at least all sound experimental science, is repeatable process and reproducible results. And what price repeatability in our analytic experiments without any metadata management, without any governance, without any understanding of data lineage? Not only that, but many of us want this data lake to become this central repository that feeds other downstream systems, including the data warehouse. And since any chain is only as strong as its weakest link, if we have no metadata management, if we have no lineage and governance in the data lake, then potentially we have none of those things across the entire information value chain in our enterprises. If we're going to talk about scientific metaphors, I think the second law of thermodynamics is in many ways a better metaphor. Probably shouldn't be any surprise to us, but shiny new technologies by themselves don't change the law of physics. And those of you that studied physics will know in particular that order does not arise spontaneously in nature. Order has to be imposed. It has to be imposed at a net cost in energy. Left to their own devices, the entropy of systems increases. There are some commentators who are claiming that a data lake will somehow spontaneously emerge from a consolidated collection of Hadoop applications. I think for that to happen, we'd have to cheat the second law of thermodynamics, and I have to tell you that I think that's frankly unlikely. I spoke to one Teradata customer recently who's doing some absolutely fabulous things with Hadoop, including integrating their Hadoop systems with their Teradata data warehouse. But 4 years after they started their Hadoop journey, they have 20 sizable application-specific Hadoop clusters. I have to question whether that's a sustainable trajectory. I predict a wave of Hadoop cluster consolidation projects coming to a number of organizations near you in the near future. Now, I have no problem with multiple clusters if each cluster is paying its own way, and I have no problem with the consolidation projects that will follow if those can cut costs and rationalize the infrastructure even further. But I do worry a little bit that some of us are trading short-term agility for mid-term sclerosis. Because when we do embark on those consolidation projects a couple of years down the road, the resources, human, capital, financial, that those consolidation projects will consume will stop us or delay us from delivering net new applications and net new analytics. I think if we can start with a governed infrastructure and avoid as many of those consolidation projects as possible, we do ourselves a big favor. And this is important because the first time we tried distributed, application-specific, file-based management of data, things got so messy that we had to invent the modern database industry. So some of the zealots that would like to uninvent the relational database management system should probably be a little bit careful what they wish for. And the rest of us just need to be mindful of that history so that we don't repeat the worst excesses of it. In summary, then, on all of that, the data lake is not yet the prototypical use of the Hadoop technology stack that some of the more hyped commentary would have you believe. But I fundamentally believe that it will be. I think the potential of a large store, centralized store of unmodeled data to which we can apply schema-on-read techniques so that we have multiple interpretations combined with an efficient platform for the computation of those algorithms that are difficult for traditional relational database management systems is an incredibly powerful idea, is already delivering value in very many organizations, even if there is not yet that large body of best practice about how to build one. And I think the Hadoop technology stack is a brilliant, brilliant fit for this requirement. The right-wing conservatives that want us to build, manage, and deploy these assets like we build, manage, and deploy data warehouses are confused. In the best case, they'll end up building something that most of us have already built already. And in the worst case, they'll actually take us backwards and back towards departmental silos of data. But the left-wing revolutionaries who'd have us believe that everything we learned about information in the last 3 or 4 decades is wrong, and that information management and governance, centralized information management and governance anyway, are for wimps, they're also equally misguided. The end of that path isn't a data lake, it's a data swamp. The much, much better metaphor, I think, for all of this actually is a data reservoir. We want these environments, we want these platforms to be designed, to be managed and governed, just not designed, managed, and governed the same way that we do those things in the data warehouse. Because this is a both-and conversation, not an either-or conversation. We're going to need both the data lake and the data warehouse design patterns in our end-to-end big data enterprise architectures. Integration really does become an absolutely critical consideration. And that's why at Teradata, we're so excited about our partnerships with Cloudera and with the other leading Hadoop distributions. I want to thank the guys from O'Reilly and Cloudera for the opportunity to come and be with you today. Thank you very much for all your time and attention, and enjoy the rest of your conference.